Hi guys, welcome to this video. This is Dr. Moorthi, working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is a lecture series of engineering mechanics. So in this lecture series, we have discussed about from the basic to some extended level, and in this video we will discuss about a topic called Newton's law of motion, and what are the different types of Newton's law of motion, and what are the applications. So first, what is Newton's law of motion? So in that we have law of motion, and we have derived three laws based on Newton's state of motion. Starts with the first law of motion. So every body continues in its state of rest or in uniform motion, either in its direction of motion, unless there is some external forces acting on the object. So if there is any external force is acting on the object, it tends to change its position, otherwise it move with the same uniform motion or in rest condition. In the second law of motion, the rate of change of momentum is directly proportional to the impressed force, and it is taken in the same direction, the direction in which the force is applied on the object, and these two factors are in directly proportional. And the third one, Newton's third law of motion. So in every action there is an equal and opposite reaction. So here the first law states that the law of inertia, and the second one law of force and acceleration, and the third one is the action and reaction. So this is the another form of three different laws of motion. Law of first law also called as law of inertia, and the second law of motion also called as law of force and acceleration, and the third law of motion is the action and reaction. So here the Newton's second law of motion, so it is described in the diagram or picture. The rate of change of momentum is proportional to the impressed force. It is the same direction. So what the force is acting on the object is directly proportional to the change of momentum. So the force is directly proportional to the acceleration. So here the rate of change of momentum is the initial momentum, final momentum minus initial momentum. And what are the different applications of Newton's law of motion? So the starting with the racing car, and the second one riding the bicycle, third one the kicking by means of kicking a football, third one the car crash. So what the third, so fourth one, so the car crash is the example for Newton's third law, or the law of force and the action and reaction. So the force in which the car hits the obstacle or the resistance, and the same amount of damage we can feel. So that is the Newton's third law. And the kicking of ball is the Newton's the example for Newton's second law. The amount of force that we are applied on the football, it is directly proportional to the distance traveled by means of the football. So that is the rate of change of momentum is directly proportional to the force applied. And then similarly it is a riding a bicycle and the racing car. So that is the example for Newton's first law of motion. So here we have another the concept based on the Newton's law of motion. That is the example for along the gravity or in the against the gravity, or the example for lift. First one, first the lift is moving in the upward direction or against the gravity. So we can get the upward direction, the force, the downward force due to the mass of lift. So here we have the downward direction, the self weight of the object, and the object is moving in the upward direction, and then the right side we have the lift is moving in the downward direction. So always the self weight is acting towards the gravity, and the motion of R, the direction of motion in the downward direction. So here the mg, that is a mass into gravitational force, that is the against it. So we have the minus one. So the net force is the capital F is equal to R, the resultant force minus R reaction force. We can take it as R is the reaction force minus M into G. So that minus M into G or inertia force indicates, that minus indicates the negative direction of motion, that is the upward direction. Whereas in the downward direction, so here we have mg minus r. So that mg positive indicates the object moving in the positive direction of y-axis. So this is the difference between a lift moving in the upward direction and in the downward direction. So thank you.